Unit 4, Lesson 4 test. Number 1. During a science experiment, a student dropped a metal ball from a height of 2 meters. The graph shows the distance the metal ball traveled from its initial position to where it hit the ground. What information does the graph give you about the speed of the metal ball over time? A. The ball travels at a constant speed. B. The speed of the ball increases over time. C. The speed of the ball decreases over time. D. The speed of the ball increases at first and then decreases as time increases. Number 2. In a swimming race, Miho swam the first 50 meters in 42 seconds. She swam the second 50 meters in 40 seconds. What was Miho's average speed during the race? A. 0.82 meters per second. B. 1.19 meters per second. C. 1.22 meters per second. D. 1.25 meters per second. Three. Which unit is used to measure distance? A. Grams. B. Seconds. C. Milliliters. Or D. Centimeters. Number 4. An athlete is running a 5-kilometer race at an average speed of 8 kilometers per hour. She has to stop to tie her shoe. After tying her shoe, she continues running at 8 kilometers per hour. Why would her average speed for the entire race be less than 8 kilometers per hour? A. The total distance she traveled was longer than 5 kilometers. B. The total distance she traveled was shorter than 5 kilometers. C. The total time she took to complete the race increased because she stopped. D. The total time she took to complete the race decreased because she stopped. Number 5. An elevator traveled 15 floors, or 50 meters, at a speed of 4.5 meters per second. What additional information is needed to determine the velocity of the elevator? A. The direction the elevator traveled. B. How long the elevator was stationary. C. How many times the elevator stopped. D. The total mass of the elevator plus anything in it. Number 6. The graph below shows the distance a car traveled in 5 seconds while moving on a freeway. What was the car's average speed? A. 0 meters per second. B. 14 meters per second. C. 28 meters per second. D. 30 meters per second. Number 7. Which of the following is a definition of motion? A. A change in position over time. B. The speed and direction of an object. C. The length of the path between points. D. A location compared to other locations. Number 8. Joanna's family drove 1,600 meters to school. The graph below represents their motion. What was the average speed during the last 3 minutes of the trip? Hint, step 1. First, determine how far Joanna's family traveled during the last 3 minutes of the trip. Step 2. Divide the number of meters by the amount of time. A. 60 meters per minute. B. 120 meters per minute. C. 180 meters per minute. D. 267 meters per minute. Number 9. 3 runners compete in a 400-meter race on an oval-shaped running track. At a certain time, one runner is 15 meters behind the finish line. Which term describes the finish line? A. Speed. B. Relative motion. C. Reference point. D. Change in position. Number 10. A student allowed 4 different objects to roll down a ramp. He measured the distance each object rolled and the time until each object came to a stop. He plotted each point and connected it with a line from the origin of the graph. Which object had the greatest average speed? A. Object A. B. Object B. C. Object C. D. Object D. Number 11. Montez read that bobcats can reach speeds of up to 30 miles per hour. What does the speed of a bobcat indicate? A. The time it takes to reach its maximum speed. B. The total amount of time it travels in one direction. C. The distance it travels to move between 2 points. D. The distance it can travel in a certain amount of time. Number 12. Tyrone wants to determine how fast a bowling ball travels when it is bowled. He uses a stopwatch to record in seconds the time it takes for the bowling ball to reach the pins. Which unit would be most appropriate to measure the length of the bowling lane? A. Meters, B. Grams, C. Milliliters, D. Celsius degrees. Number 13. The graph below represents the time and distance traveled by 4 different toy cars. What was the average speed of car A? A. 6 meters per second, B. 3.2 meters per second, C. 0.92 meters per second, D. 0.33 meters per second. Number 14. Which 2 measurements are needed to determine the speed of an object? A. Position and time, B. Distance and time, C. Position and direction, D. Distance and direction. Number 15. Which of the following would be best measured in kilometers? A. The height of a golf ball travels into the air. B. The distance a snail moves each second. C. The length between 2 walls of a room. D. The distance a plane travels during flight. Number 16. An airplane leaves New York to fly to Los Angeles. It travels 3,850 kilometers in 5.5 hours. What is the average speed of the airplane? A. 700 kilometers, B. 700 hours, C. 700 kilometers per hour, D. 7,000 hours per kilometer. Number 17. This distance time graph shows the speeds of four toy cars. Which car travels the farthest? Hint. Step 1. Compare the lines on the graph that represent each of the cars. 2. Determine which car traveled the greatest distance per second. A. Car A, B. Car B, C. Car C, or D. Car D. Number 18. The distance time graph shows the speed of four toy cars. How much faster did car A travel than car C? Hint. Step 1. Find the average speeds of car A and car C by dividing the distance by time. Step 2. Subtract the speed of car C from the speed of car A. A. 1 meter per second, B. 3 meters per second, C. 5 meters per second, D. 10 meters per second. Number 19. How many meters in a kilometer? A. 100, B. 1,000, C. 1 divided by 1,000, D. 10,000. Number 20. What is the energy transformation on the roller coaster shown from point W to point X? A. From potential to kinetic, B. From kinetic to potential, C. From electrical to potential, D. From nuclear to mechanical.